Hi one and all. In last earlier sessions, I we discussed the indeterminate forms 0 by 0 and infinity by infinity. So in this session, I would like to discuss one more interesting indeterminate form, that is 0 into infinity or infinity into 0. So yes, when we are applying a limit to a function f of x and g of x, when it takes 0 by infinity form, so in that time first we have to reduce that one into 0 by 0 for infinity by infinity form. So after that, so after so then we can evaluate that by using L'Hospital's rule. Okay, so you remember that L'Hospital rule can be applied only when that indeterminate form, so when it takes the indeterminate form 0 by 0 or infinity by infinity. In other cases it is not possible to apply. Now 0 by 0 infinity by infinity ಫಾರಮಿಗೆ ಬಂದಾಗ ಮಾತ್ರ, ಇಂಡಿಟರ್ಮಿನೆಂಟ್ ಫಾರಮಿಗೆ ಬಂದಾಗ ಮಾತ್ರ ಎಲಾಸ್ಪಿಟಲ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡ್ಬೋದು. ಬೇರೆ ಟೈಮಲ್ಲಿ ಎಲಾಸ್ಪಿಟಲ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡೋಕ್ಕೆ ಬರಲ್ಲ. ಸೊ ಬೇರೆ ಟೈಮಲ್ಲಿ ಸೊ 0 ಇಂಟು ಇನ್ಫಿನಿಟಿ ಫಾರ್ಮ್ ತಗೊಂಡಾಗ ಅದನ್ನು ಒನ್ಸ್ ಅಗೇನ್ 0 by 0 ಅಥವಾ ಇನ್ಫಿನಿಟಿ ಬೈ ಇನ್ಫಿನಿಟಿ ಫಾರ್ಮ್ಗೆ ರಿಡ್ಯೂಸ್ ಮಾಡಿಕೊಂಡು, so after that we can apply the L'Hospital rule. Okay, see one example of 0 into infinity form. As here evaluate limit x tends to pi log of x minus pi into tan x, log of x minus pi into tan x is this, let k is equal to, take this function, let k is equal to, it is take this function is k is equal to limit x tends to pi into log of x minus pi into tan x. You apply the limit to this function, it is log of pi minus pi into tan pi, pi minus pi into tan pi, so that is log 0 into tan pi. As all of you know that log 0 is minus infinity into tan pi is 0. So it takes infinity into 0 form. So irrespective of its sign, okay, it is infinity into 0 form, is indeterminate. Okay, so now you take this one as k is equal to limit x tends to pi. So this is log of x minus pi, that as it is, divided by, you take this tan x to denominator, then it becomes cot x. Tan x can be written as 1 by cot x. Tan x is equal to 1 by cot x. Now you apply the limit, so then it is, which is equal to log of pi minus pi by cot pi. So pi minus pi is log 0 by cot pi. Yes, log 0 is minus infinity by cot pi is infinity, is indeterminate. ಸೊ ಈಗ ಏನು ಮಾಡಿದ್ವಿ ನಾವು, 0 ಇಂಟು ಇನ್ಫಿನಿಟಿ ಇರೋದನ್ನ ಇನ್ಫಿನಿಟಿ ಬೈ ಇನ್ಫಿನಿಟಿ ಫಾರಮಿಗೆ ರಿಡ್ಯೂಸ್ ಮಾಡಿದ್ವಿ. ಸೊ once it takes infinity by infinity form, now you can apply the L'Hospital rule. Apply L'Hospital rule. Apply L'Hospital's rule. So that is k is equal to limit x tends to pi, the differentiation of log of x minus pi is 1 by x minus pi by differentiation of cot pi is, cot x is minus cosecant square x. Differentiation of cot x is minus cosecant square x. Once again you can apply this limit, and you notice the values. Okay, so k is equal to, you simplifying this, then you apply the limit x tends to pi. So take this cosecant square x to numerator, then it is sin square x by, so then denominator we have x minus pi. So now you apply the limit minus sin square pi by pi minus pi. So you know that sin pi is 0, 0 by 0 is indeterminate. Okay. So again it takes 0 by 0 form. Apply L'Hospital rule. Apply L'Hospital rule to this one. So after applying L'Hospital rule, so then k is equal to limit extends to pi. Differentiation of sin square x is minus 2 sin x cos x divided by differentiation of x minus pi is 1. So you take this is k is equal to minus 2 sin pi into cos pi. If you apply the limit to this, it is like this. What is the value of sin pi? Sin pi is 0, cos pi is minus 1. 0 into anything is 0. So therefore the limit k is equal to 0 in this case. Limit k is equal to 0. Again, one more example of the same type is limit of x log of tan x, x into log of tan x. So let k is equal to limit x tends to 0, it is x into log tan x. If you apply the limit, it is 0 into log of tan 0. So that is 0 into infinity, because tan 0 is 0, log of 0 is minus infinity. So 0 into infinity is indeterminate. So if it takes indeterminate form, now you can write this one as ಹೇಗೆ ಬರಿಬಹುದು ಇದನ್ನಂದ್ರೆ, so you can write this is k is equal to limit x tends to 0, this is log of tan x divided by, you can write this x is 1 by x. You take this x to denominator, top denominator, that is 1 by x. Now you apply the limit, k is equal to log of tan 0 by 1 by 0. So tan 0 is 0, log of 0 is minus infinity by 1 by 0 is infinity. Anything divided by 0 is infinity. So minus infinity by infinity is indeterminate. So ಇಲ್ಲಿ ಏನು ಮಾಡಿದ್ವಿ ಅಂದರೆ ನಾವು infinity by infinity form reduce ಮಾಡಿದ್ವಿ. Once it reduces to infinity by infinity form, now you can apply L'Hospital rule. So apply L'Hospital rule now. Apply L'Hospital rule. So then k is equal to limit x tends to 0. Differentiation of log of tan x is 1 by tan x. Again differentiation of tan x is secant square x. This divided by differentiation of 1 by x is minus 1 by x square. Differentiation of 1 by x is minus 1 by x square. So now, so secant 0 is 1. Okay, you do one thing, you write this is k is equal to limit x tends to 0 minus x square into secant square x by tan x. So this, you can bring this x square to numerator. So then it is x square into secant square x by tan x. Okay, again you take this is k is equal to limit x tends to 0 into minus x. So limit x tends to 0 into x by tan x. Limit x tends to 0 into secant square x. Split ಮಾಡಿ ಲಿಮಿಟ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ದೇನೆ. ಫಸ್ಟ್ ಬರೀ ಒಂದು x ತಗೊಂಡಿದೆ ಇಲ್ಲಿ. So then next step I am taken this is x by tan x. So in third one, so it is a limit of secant square x by and x tends to 0. So okay, if you apply the limit to this, which is equal to, when x tends to 0, this becomes 0. So limit of x by tan x when x tends to 0 is 1. Secant 0 is 1. So but anything you multiply with 0, it gives 0 only. So the limit value k is equal to 0. Limit of this is 0. Okay, if possible, you solve this limit. Okay, it is log of sin x by cot x. It's okay. I think it's enough. This. So next, one more indeterminate form is infinity minus infinity. So when it appears infinity minus infinity form, so once again with the simplification, we can reduce that one to 0 by 0 or infinity by infinity form. So you know what purpose we are reducing to 0 by 0 or infinity by infinity form is. So if you reduce that indeterminate form infinity minus infinity to 0 by 0 or infinity by infinity form, then we can easily apply the L'Hospital rule. ಸೊ L'Hospital rule ಅಪ್ಲೈ ಮಾಡಬೇಕು ಅಂದರೆ 0 by 0 ಅಥವಾ ಇನ್ಫಿನಿಟಿ ಬೈ ಇನ್ಫಿನಿಟಿ ಫಾರಮ್ಗೆ ಬರಬೇಕು. ಸೊ ಬಂದಿಲ್ಲ ಅಂತಂದರೆ ಹೀಗೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ 0 by 0 ಅಥವಾ ಇನ್ಫಿನಿಟಿ ಬೈ ಇನ್ಫಿನಿಟಿ ಫಾರಮ್ಗೆ ರೆಡ್ಯೂಸ್ ಮಾಡಿಕೊಂಡು, ಸೊ ದೆನ್ ಯು ಕ್ಯಾನ್ ಅಪ್ಲೈ ದ L'Hospital's rule. Yes, one example of that form, infinity minus infinity form is given here. Limit x tends to 0. So cosecant x minus cot x. Limit x tends to 0. Cosecant x minus cot x. Cosecant x minus cot x. So that is k is equal to, apply the limit cosecant 0 minus cot 0. As all of you know that cosecant 0 is infinity. Cot 0 is also infinity. It is infinity minus infinity form is indeterminate. Okay, then you simplifying this one as ಯೋಚನೆ ಮಾಡಬೇಕು. You should think how to reduce this one to 0 by 0 or infinity by infinity form. As all of you know that cosecant x can be written as 1 by sin x minus cot x can be written as cos x by sin x. So both the denominator is sin x. So you can write this as k is equal to limit x tends to 0. You can write this is 1 minus cos x whole divided by sin x. If you apply the limit, it is 1 minus cos 0 by sin 0. As all of you know that cos 0 is 1, 1 minus 1 is 0, sin 0 is 0, is indeterminate. So now it reduces to 0 by 0 form. So when it takes 0 by 0 form, you can apply L'Hospital rule. Apply L'Hospital rule. Apply L'Hospital's rule. So then we have k is equal to limit x tends to 0. Differentiation of 1 is 0 minus differentiation of cos x is minus sin x divided by differentiation of sin x is cos x, which is equal to limit x tends to 0 minus of minus plus sin x by cos x is tan x. You apply the limit to tan x, it is tan 0. As all of you know that tan 0 is 0. Tan 0 is 0, therefore limit value k is equal to 0. Limit value k is equal to 0. Similarly, you see one more example. Limit x tends to 0, 1 by x square minus 1 by x tan x. So you take this limit is let k is equal to limit x tends to 0, 1 by x square minus 1 by x tan x. If you apply the limit to this, it is 1 by 0 minus 1 by 0 tan 0 is also 0. Anything by 0 is infinity minus infinity form. Okay, so now you simplifying this one as limit extends to 0. Here you take that x square tan x is the LCM. X square into tan x is the LCM. X square tan x LCM ಆದರೆ so ಇದರಲ್ಲಿ x square cancel ಆದರೆ tan x is remaining. Tan x into 1 is tan x minus, if you cancel this x square tan x with x tan x, divide ಮಾಡ್ಕೊಂಡ್ಬಿಡಿ x square tan x by x tan x. Tan x cancel, x cancels. What is remaining? X into 1 is x. Okay, now you can apply the limit, or first you cancel the tan x, then you apply the limit. ಈ denominator ಅಲ್ಲಿ tan x ಗಳು ಇರಬಾರ್ದು ಅಂತ ಹೇಳಿದೆ ನಾನು. sin x tan x ಇದ್ರೆ first we have to cancel that sin and tan x. So okay, then what method we can apply? So that is k is equal to limit x tends to 0. This is tan x minus x by x square into limit x tends to 0. In denominator we have tan x. In numerator you take one extra x and you multiply this denominator with x. To balance this x you multiply this x here. Okay, so the x cancel, then it gives the same term. Now k is equal to limit x tends to 0. This is tan x minus x by x square into x is x cube, and its limit value is 1. ಇದೇನಾಗುತ್ತೆ, ಇದು 1 ಆಗುತ್ತೆ ಇದು. Okay, now you apply the limit to tan x minus x by x cube. ಇದಕ್ಕೆ ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ನಾವೀಗ k is equal to tan 0 minus 0 by 0. So that is 0 by 0 form is indeterminate. So now you can apply L'Hospital rule. Okay, then k is equal to limit x tends to 0. Differentiation of tan x is secant square x minus differentiation of x is 1 divided by differentiation of x cube is 3x square. So if you apply a limit, once again it takes 0 by 0 form, or in other words you can simplify and apply the limit. So ಒಂದು ಇಲ್ಲ ಇನ್ನೂ 2 ಸ್ಟೆಪ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕಾಗುತ್ತೆ. ಹಾಗೆ ಮಾಡ್ತಾ ಹೋದ್ರೆ ಇನ್ನೂ 2 ಸ್ಟೆಪ್ ಬೇಕಾಗುತ್ತೆ. Otherwise you simplify and end the values here itself. So secant square minus 1 is tan square x. By using identities, ಗೊತ್ತಲ್ಲ trigonometric identities, you know that secant square x minus 1 can be written as tan square x. Tan square x by 3x square with the limit x tends to 0. Again k is equal to, take 1 by 3 outside, it is a constant. Limit x tends to 0. Tan x by x whole square. Tan square x by x square can be written as tan x by x whole square. So now its limit is 1 by 3 into 1 square, so that is 1 by 3 only. So therefore the limit k is equal to 1 by 3. Okay, like this we can evaluate infinity minus infinity forms. Yeah, so I'll solve this one more problem, the same. So let k is equal to limit x tends to 0. This is 1 by x square minus cot square x. If you apply the limit, it is 1 by 0 minus cot square 0. As 1 by 0 is infinity, cot 0 is also infinity. Infinity minus infinity is indeterminate. So now you write this is k is equal to limit x tends to 0. As we can simplify this as 1 by x square minus cot square x can be written as 1 by tan square x. Cot square x can be written as 1 by tan square x. You take x square tan square x is the LCM and simplifying this, k is equal to limit x tends to 0. Here you take x square x square tan square x is LCM, then we have tan square x minus x square divided by x square tan square x. I already told you that if tan x or sin x is and tan x appears in the denominator, first we have to remove it from the denominator. So ಯಾಕೆಂದ್ರೆ ನೀವು ಎಲ್ಲ ಹಾಸ್ಪಿಟಲ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡೋಕೆ ಈಸಿ ಆಗಬೇಕಂದ್ರೆ we have to remove the tan. So you know that limit x tends to 0 into this is tan square x minus x square divided by x square into, you write this is limit x tends to 0, you multiply numerator with x square and denominator we have tan square x. To balance this you multiply x square in the denominator, ಮತ್ತೆ x square ನಿಂದ denominator multiply ಮಾಡ್ಕೊಳ್ಳಿ. So now we have k is equal to limit x tends to 0, this is tan square x minus x square divided by x square into x square is x to the power 4, and this becomes x by tan x whole square when x tends to 0 is 1. Now you apply limit to this, k is equal to, so it is tan square 0 minus 0 by 0. So that is 0 by 0 is indeterminate. So when it takes indeterminate form, so then you apply L'Hospital rule. 0 by 0 idre L'Hospital rule apply ಮಾಡಬಹುದು. Apply L'Hospital's rule. L'Hospital's rule. So then we have k is equal to limit x tends to 0. Differentiation of tan square x is 2 tan x. Again differentiation of tan x is secant square x minus differentiation of x square is 2x. This divided by differentiation of x to the power 4 is 4x cube. 4x cube. To this you apply the limit, k is equal to, so 2 into tan 0 into secant square 0 minus 0 by 0. If you put x is 0, it is 0 only. Okay. So say tan 0 is 0, 0 minus 0, 0 by 0 is indeterminate. So again apply L'Hospital rule. Apply L'Hospital rule. ಮತ್ತೆ L'Hospital rule apply ಮಾಡಿದ್ರೆ, so then k is equal to limit x tends to 0. Yes, we have to differentiate this 2 tan x secant square x minus 2x by 4x cube. ಇದನ್ನು differentiation ಮಾಡಿದ್ರೆ you take 2 tan x as it is. Differentiation of secant square x is 2 into secant x. Differentiation of secant x is secant x into tan x plus differentiation of 2 tan x is 2 into differentiation of tan x is secant square x, and you keep this secant square x as it is. A secant square x ಹಾಗೆ ಇಟ್ಕೊಳ್ಳಿ. Again differentiation of 2x is minus 2. Differentiation of 2x is minus 2. This divided by differentiation of 4x cube is 12x square. It is 12x square. So now we have to simplify this, limit x tends to 0. So this is 2 2s are 4. 4 tan x into tan x, tan square x. 4 tan square x into secant x into secant x, secant square x, plus here it is 2. If you take 2 common factor, here it is remaining is secant square x into secant square x, that can be written as secant square x whole square minus 1, because we have taken 2 is a common factor. Okay, now it is in denominator, it is 12x square. again, which is equal to limit x tends to 0. So take this is 4 tan square x into secant square x plus 2 into, you see, it is like a square minus b square form. So it is like a square minus b square. A square minus b square can be written as a plus b into a minus b. A plus b into a minus b divided by 12x square. If you are applying the limit and applying the L'Hospital rule, then it becomes lengthy. So to avoid that, I just go on simplifying in this step itself. Right? Yeah. So now it is, which is equal to limit x tends to 0. This is 4 tan square x into secant square x plus 2 into secant square x plus 1 into, by using trigonometric identities, secant square x minus 1 can be written as tan square x, that divided by 12x square, which is equal to limit x tends to 0. You take 2 tan square x common factor. If you take 2 tan square x is common factor, if take 2 tan square comes outside, remaining is 2 secant square x. First term ಅಲ್ಲಿ ಏನು ಉಳಿಯುತ್ತೆ, 2 secant square x ಉಳಿಯುತ್ತೆ. Plus, if this 2 and tan square x comes outside, remaining here is secant square x plus 1. This whole divided by 12x square. Here this 2 ones are 2 6 are. Now you apply the limit like this. So now which is equal to 1 by 6 is a constant, you can keep it outside. Limit x tends to 0. This is tan square x by x square. Tan square x by x square again into limit x tends to 0. 2 secant square x plus secant square x is 3 secant square x. 2 secant square x plus secant square x is 3 secant square x plus 1. Okay. Now you apply the limit, which is equal to 1 by 6 into, all of you know that tan x by x when x tends to 0 is 1. So square is there, so you can write it is 1 square. And to apply the limit to this, it is 3 into secant 0 plus 1. Secant 0 plus 1, which is equal to, this is 1 by 6. 1 by 6 into, this is secant 0 is 1. 1 into 3, 3 plus 1, 4 ಆಯಿತು, which is equal to 2 by 3. 2 2s are 2 3s are 2 by 3 is its final answer. Okay, like this we evaluate infinity minus infinity forms. So yeah, some more examples are there here. You try to solve this secant x minus tan x when x tends to pi by 2, and 1 by x minus log of 1 plus x by x square. Here you take x square is the LCM and evaluate this. And one more example. So 1 by x square minus 1 by sin square x. Say take sin square x, tan x square into sin square x is the LCM. Try to evaluate this. Okay, thank you, and I continue in next coming sessions.